Hello guys, welcome to BYJU'S Exam Prep, the most comprehensive preparation app for all the competitive exams. So today I am going to teach you theory of computation. So the most expected questions of ISRO and NIELIT. So please join quickly and mark your presence. So I hope I am audible and visible to all of you. Am I audible and visible? Please confirm me once. Yes. Is my audio, video, everything is clear? Just confirm me once. Okay, so you can use this chat box for communicating with me and join quickly. And today's session is about theory of computation. So ISRO plus NIELIT 2023, the most expected questions of theory of computation. Hello, Harsha. Yes. Thank you, Harsha, for your response. So shall we start the session? And before I begin, so let me introduce myself. Myself, Murali Krishna Bokkasamudram. I am having 21 plus years of teaching experience, both in the GATE and also I worked in different engineering colleges. And I am topper of different NPTEL courses, including theory of computation. That's what I am teaching you right now. And I am certified as International Engineering Educator through ISIP certification program. And I have mentored more than 50,000 students across the country in different core areas of computer science. That includes theory of computation, operating systems, computer organization, computer networks, digital logic, and ICT, information and communication technology. So these are the areas where I am expertise. And please let me know. And if my audio, video, everything is clear. Hello, Harsha. Thank you for your response. Okay. And before I begin the session, so I request everybody to please do subscribe the channel if you have not yet done it. And also, please do share with your friends. And for getting all notification, you can just press the bell button. And also, we are providing more content in the YouTube for you for ISRO, NIELIT, and also for GATE. Okay, so different series we plan and technical, non-technical, all those things. And please try to make use of this. And there is one workshop by our faculty Rakesh Talreja sir. He's having MTech from IIC Bangalore, and this is regarding how to ace the GATE exam in just 8 months. And this free live interactive workshop is on 20th June, that is tomorrow at 7:30 p.m. So all of you please try to make use of this and try to utilize this opportunity to learn how to prepare for GATE in just 8 months by the GATE topper and done MSc MTech in IIC Bangalore. Okay. So meanwhile, if you have any doubt, please ask me. And let us straight away move on to the first question. Consider the following finite automata given below. Okay, which of the following is true? So we need to find out a true statement here. FA1 is a subset of FA2 and FA2 is a subset of FA1 and FA1 and FA2 same and none of the above. So all of you quickly and respond to this. So two finite automata are given. So the inputs for both the finite automata are same, A comma B, and let it be the machine M1 and let it be the machine M2. Okay, and if you want, you can name those states and do let me know. I'm just giving you half minute of time for thinking about it. So the subset operation basically regarding the languages. So FA1 is subset of FA2 means language of M1 is a subset of language of M2. It's a proper subset. And FA2 subset of FA1 means language accepted by the machine 2 is a subset of language accepted by the machine 1. And both are equivalent and none of the above. Okay. So I think some of you can answer it. Hello, Harsha. Is my audio, video, everything is clear? I hope so. If not, please do let me know. And please do share the class information with your friends. Okay. Have you shared it? And you can also join my Telegram group. Okay. Now, basically, the language accepted by machine M1 and machine M2 both are same because both will accept all combinations of A's and B's ending with A. So A plus B whole star A, it is nothing but all combinations of A's and B's ending with A. So single A accepted, BA accepted, AA accepted, etc. Yes, exactly. Top 10, you are right. Option C is the right option. Very good. And machine M2 also, Very simple actually. If you name the machine M2 as states A, B, C, and B is a final state, A and C are non-final state, the state A is equivalent to C. So when you club A and C into single state, so B will be the final state and this machine will be equivalent to this only. So this AC is clubbed and B. So with the minimization of M2 into M1, both will accept the same language. So that language is what? All strings of A's and B's ending with A. You can also verify. For example, here also in the machine M2 also single A accepted and BA accepted, AA accepted, all those things. So both are deterministic finite automatas. So every state is accepting all inputs but only once. And this session will be useful for GATE also and as well as ISRO and NIELIT. So basically these are the most expected questions of ISRO and NIELIT. And definitely this model they can't go beyond this level of questions. And if you see all the questions, and please do stay in the session till the end of the session so that you will see the depth of this content. And the second one, what can be said about regular language L over A whose minimal finite automata has two states? Quickly, can anybody respond quickly? And please do share the class information with your friends. This is more important. Yes, that's great. L must be a power n such that n is odd and L must be a power n such that n is even. Option D, either L must be a power n is odd or L must be a power n is even. So if you observe this, a power n is odd means, so we can have number of A's odd. So alphabet remains only one input, so that is A. Alphabet remains one input. So this is A followed by AA whole star. So odd number of A, single A, we can have single A, we can have triple A, we can have 5 A's, like that number of A's are possible. So for this actually if you draw the machine, only two states are sufficient. So one non-final state and one final state and A can be given. This is the DFA for odd number of A's. Even for even number of A's, the regular expression is like AA whole star. Okay, and for this we can have a starting state, final state, like we can have strings like epsilon, single, double A, 4 A's, even number of A's. Okay, so A's can be given like this. Same transitions, but final state is changed. So for A and B we got two states, but for the option C, this is A star actually. A star means only one state. We can have a machine like this. This is for A star. So this is not a right answer. Either it should be option A or option B. That means option D is right. Either L must be a power n is odd or L must be a power n is even. It is not only option B or option A. Okay. So I hope everybody got my point. And please do let me know if you have any doubt on any question during the tenure of this lecture. Okay. Fine. And if you are having more interactive, then definitely I will also do my better. Yes. Please be more interactive and for utilizing this class effectively. Now coming to the question number 3. Consider a DFA over alphabet sigma is equal to a comma b accepting all strings which have number of A's divisible by 2 and number of B's divisible by 3. And what is the minimum number of states that the DFA will have? So what is the criteria here? Total number of A's must be multiple of 2, total number of B's must be multiple of 3. So how can we solve this? I will also show you the DFA. First you respond with your option. Have you shared with your friends, and do like this session if you are really liking it, and just forward your friends groups and do subscribe the channel. Okay, fine, that's great. Yes, very good, top 10, you are right. So 6, option A is right option, because number of A's divisible by 2, number of B's divisible by 3. So you require 2 into 3 states minimum in the DFA. And the DFA also will construct. So it is like this. DFA starting state is a final state. As the A's are multiple of 2, so we can take A's like this. 2 A's, 3, 4 A's like that. And B's are multiple of 3, we can take B's like this. And initial state is final state. Epsilon is also acceptable. And after every B also you can get number of A's multiple of 2 like this. After 2 B's also you can get number of A's multiple of 2. Okay, and after every A, the number of B's also you can get multiple of 3 like this. You can take B's like this. Okay, so there are 2 into 3 states, total 6 states. Option A is the right option. Okay, now coming to the next question, question number 4. Minimum number of states required in a DFA to accept L is equal to A power N, B power M, C power K, N comma M comma K greater than or equal to 0. Can anybody answer it? So I'll just give you a hint. 1 or more A's followed by 1 or more B's. That means A followed by any number of A's, because all are minimum starting with 1. And then B's followed by any number of B's. And then C's followed by any number of C's. So AA star, BB star, CC star. So alphabet for this is sigma is equal to A comma B comma C. Yeah. How many states? Yes, yes. Respond. You want me to give more time? Yes. Okay. So what is the smallest string here? ABC. So for ABC, we have to go for a final state. A followed by B followed by C. We have to go for a final state. A followed by any number of A's, B followed by any number of B's, and C followed by any number of C's. A star, B star, C star. And we require to have a dead state because the first state, let us name them like this is the Q0, this is the Q1, this is the Q2, and Q3. Q3 is a final state. Okay, if there is a dead state, you have to include the dead state also. So Q0 A is defined, B and C are missing, right? So either B or C should go to dead. Q1 A and B are defined, but C is missing. C will be sent to dead. And Q2 B and C is there. A is missing. A will be sent to dead. And Q3 C is there. A B is missing. So A or B will be sent to dead. And dead state, either A or B or C, it will go to dead. Total, it requires 5 states. Option C would be right option. Yes, Pankaj, sir, I am a new student in GATE. I have a question. How many GATE rank required for IITs and NITs? That depends on the IIT. It is different for different IITs. Okay, it's always safe if you get rank below 500. Okay, na, Pankaj. But if you wanted to get IIT of your choice, if you get below 100, it is more appropriate. Okay. Yes, top 10, you are correct. Now let's move on to the next question. Question number 5. Which of the following regular expression given below represents the following DFA? Actually, the DFA I will mention here. Just a moment. DFA is like this. Actually, it is missed here. This is a DFA. This is a DFA given. And which of the regular expressions given below represents the following DFA? Option A, L1 and L2 only. Option B, L1 and L3 only. Option C, L2 and L3. Option D, none of these. So this is 0 star 1 followed by 1 plus 0 0 star 1 whole star. Second one, 0 star 1 star 1 plus 1 1 star 0 star 1. The third one, 0 plus 1 whole star 1. All combinations of zeros and ones ending with 1. These are the combinations. Okay. Can anybody answer this? Yes. And please don't hesitate to ask your doubts if you have any doubt. And just also respond to the questions. And if you know the answer, please try to answer it. Yes, yes. Top 10 has given option A, but that option A is wrong. Sorry, top 10. Yeah, you removed it. No. Option C also wrong. I'll tell you, 1 and 2 are correct. 1 and 3, sorry. So that means option B is the right option. I will tell you, this is all combinations of zeros and ones ending with 1 is nothing but 0 plus 1 whole star 1. Okay. And this one also equivalent to that, because the first one can be written like this, 0 star 1 followed by 1 plus 0 0 star 1. You can take 1 as a common. So we can write this as a epsilon plus 0 0 star, epsilon plus 0 0 star of 1, and then whole star. Okay, so this is 0 star 1, and epsilon plus 0 0 star is nothing but 0 star. 0 star 1 whole star. So this can be written as 0 star 1 followed by 0 star 1 whole star is nothing but 0 star 1 whole plus 1 or more times it will come. So this one and this one both are same. This is also provide all combinations of zeros and ones ending with 1. But the problem with this is contiguous zeros followed by ones, contiguous ones followed by 0 followed by 1. But if you wanted to have a string like 1 0 1 0 1 0 1 1 or 0 1 0 1 0 1, this type of strings ending with 1, but this type of strings are not recognized by this regular expression. But this one 1 and 3 can give you any string ending with 1, but 2 is missing some of the ending with 1 strings like this and like this. Okay, so option B is the right option. I hope everybody understood this. So can I go for the next? Please do let me know if you have any doubt or any concern. Okay, now? Fine. Thanks for liking this session, and please do like it and also share with your friends. And the subscription advantage I am telling you, as we are providing more technical content and also general sessions, guidance sessions and all, post-grade guidance also. So please try to make use of this and subscribe it so that it is very easy to access, and also you can just press on the bell button for getting notifications. Shall I go for the next question? Okay, so question number 6. The Epsilon NFA accepts which language? So here Q2 is final, Q4 is final, Q5 is final, and these are the transitions. Epsilon followed by 1 and zeros are given. Here 1 followed by 0 or 1 with epsilon is going to Q5, and with 1 it is going to Q4. Which regular expression is providing exact expression for the given finite state machine? Okay, so are you answering it? How much time you want? Please respond. So none of you are asking any doubt here. I think most of you are aware of this subject. And if you have a doubt also, please ask me. I'm here to. Am I audible? Is my audio, video, everything is clear? Yes. Fine. That's great. Okay. Now coming to Epsilon NFA accepts which language? So this is, there are two paths here. From QNAT, there is a path on upside and a path on downside. So first Epsilon. Okay, we are going with epsilon. Then after that, single one is accepted. After 1, 0, 1, 0, 1 can be repeated. After 1, minimum after 1, 0, 1, 0, 1 can be repeated any number of times. 1 followed by 0, 1 whole star is one path from initial state to final state. And from initial state to this final state, actually, 1 followed by 0 or 1 whole star followed by epsilon. 1 followed by 0 or 1 whole star followed by epsilon is nothing but 1 followed by 0 or 1 whole star only. And this path is 1 followed by 0 or 1 whole star 1. So actually 1 followed by 0 or 1 whole star gives you all combinations of zeros and 1 starting with 1. And the strings going from Q0 to Q4 also a part of this. So it's a subset only. So that's why we can write it as a 1 of 0 1 whole star is one path, or 1 followed by 0 plus 1 whole star. 1 followed by 0 plus 1 whole star. And there is no need of putting this one because with epsilon I am going to final state. Even 1 0 also acceptable, 1 1 also acceptable. This 1 1 is here it is there, and here also there. So it will become a subset. So that's why we write 1 of 0 1 whole star plus 1 of 0 plus 1 whole star. Option C is the right option. Yes, Dolkar, actually you have taken only this path, but this path 1 followed by 0 plus 1 whole star 1 is a subset of this. That's why this is also included here. So it is finally combination of both. So option C would be right option. Okay. Shall I go for the next? And still if you have any doubt, Dolkar, you could ask. Salve Dolkar. And my friends, please do forward this session with your friends, and let's move on to the next. Question number 7. Let W be any string of length n in the combination of zeros and whole star. Let L be the set of all substrings of W. What is the minimum number of states in the non-deterministic finite automata that accepts L? So of length n, substrings. So you take a string of length n. For accepting all the substrings, how many minimum states are required in NFA? So irrespective of this alphabet, I'll tell you one thing. Let us suppose alphabet something like some W, one string W is 0, 1. And substrings are including epsilon, proper and improper. So epsilon is one substring, 0 is one substring, 0, 1 is one substring. Okay, so that means epsilon will be accepted, single 0 is accepted. Okay, and single 1 also should accept. Sorry, single 1 is also one substring. So single 0 should accept. Okay, 0, 1 also should accept, and single 1 should accept. That's it. 3 states for length 2. And in general, for example, if I take W is equal to A, B, C, D. So for a substring of length n value is 4. So A is one substring, B is one substring, C and D, and including epsilon I am writing. So AB is one substring, BC is one substring, CD is one substring. ABC is a substring, BCD is a substring, then ABCD is a substring. Like this it will come. And as far as the machine is concerned, starting state is a final state, and single A is acceptable, AB is acceptable, okay, and ABC is acceptable, ABCD also acceptable, and then AB single A, single B should accept, na? So B should go to this, otherwise it will accept BB. B accepted, BC accepted, BCD accepted, and we should accept single C. Single C means you can send single C to this, so that C accepted, CD accepted. Single D, you can send D to this, single D accepted. So all substrings including epsilon accepted. For a length 4, we got 5 states. So it is n plus 1. Option A is the right option. Is it clear? Now let's move on to the next question. Question number 8. Which is the complement of the language accepted by the NFA shown below? First of all, what is the language you should check? Then a complement of language. So let it be a machine M. So language accepted by the machine M is what? Minimum string accepted is A. Then A epsilon epsilon A. So A accepted. A epsilon epsilon A epsilon epsilon A. So triple A also accepted. And 4 A's also accepted, like this. So this is nothing but language accepted by the machine M is A plus. Is A plus. But a complement, actually what is alphabet? Complement of any language is equal to sigma star minus L. What is the sigma star? As alphabet sigma is equal to A, as alphabet sigma is equal to A, sigma star is nothing but A star, minus L is nothing but is A plus, A star minus A plus is epsilon. So option B is the right option. Hope you got my point. Is it clear, everybody? Yeah, please do like the session if you are really liking it. Don't forget liking the session if you are really liking it, and also please share with your friends. Now coming to the question number 9. Yes, consider the finite automata in the figure below. What is the set of reachable states for the input string 0, 0, 1? So this is looking NFA, right? Non-deterministic finite automata, because on a state we can have multiple inputs. So like Q0 on 1 is defined twice. If more than one time defined, or if epsilon is, if phi is there, it is NFA. Okay, so what is the string W? Something like string X is equal to 0, 0, 1, 1. So in response to the string, what will be the different reaching states? So multiple reaching states are possible in NFA, but in DFA only one reaching state, either it is a symbol or it is a string. So now there is a procedure for it. So transition of Q0 is the initial state. Q0 on 0, 0, 1, 1. So the first input that is encountered is 0. So Q0 on 0, it goes to only Q0. So we can say it is a Q0, and next is 0, 1, 1. Again we got Q0, 0, Q0, 0, again Q0. So it is a transition of Q0 1 1, and Q0 on 1 it goes to Q0 as well as Q1. So that is nothing but transition of Q0 Q1 comma 1. So we have to take union of these two. So transition of Q0 on 1 union Q1 on 1. So what is a Q0 on 1? Q0 on 1 is Q0. Q1 on 1 is Q0 on 1 is Q0 Q1 and Q2. So we will get the result is Q0 on 1 is Q0 Q1 and Q1 on 1 is Q2. So union of these two is Q0 Q1 Q2. Option A is correct. Yes, Salve Dolkar, you are right. Shall I go for the next? Shall I go for the next? Okay, fine. Now coming to the question number 10. Minimum number of states required in a DFA to accept all strings over alphabet 0, 1, where each string should have odd number of ones and ending with 0. It's a very good question, and you require to know minimum number of states. Just for your reference and for hint, I am giving you some of the strings. Odd number of ones and end with 0 means total number of ones must be odd and each string is supposed to end with 0. So we can have 10 or 100 or 10110. Total number of ones must be odd, and zeros, for example 0101, this type of strings also can be acceptable. Finally, ending should be 0, and a total number of ones, if we count, maybe contiguous or non-contiguous, it should be odd number of ones. Okay, minimum numbers of states required. We can construct. Yes, anybody can answer this question? It's a challenging question actually. This type of questions, if you practice, it will be a cakewalk for you to answer any type of question in the ISRO mostly. In the NIELIT, a little bit of less weightage is there for theory of computation, but not in the ISRO. ISRO is very high weightage for theory of computation. Okay. Yes, shall I go ahead with the solution? Okay. So minimum string, as I told you, 10. So I can take, for example, state A is a starting state. For 1, I am going to state B. 1 should not be accepted because it should end with 0. 10 is a minimum string. After going to final, any number of zeros also can accept because it ends in 0. And before this one, any number of zeros can be there, like 010 acceptable. It is ending with 0 containing 11. And also odd number of ones means if you take contiguously, single one followed by 0, triple one followed by 0, 5 ones, like this it will go. And C, 1 is missing now. 1 if we send to B, it will accept even ones. If it send to C, it will end with 1. So send to A. So that 10110 kind of strings also will be acceptable. So this is the DFA with the minimum number of states. So option A is the right option. Hope everybody understood this, and please kindly let me know if you have any doubt or any concern related to this. And if you're okay, I will move forward to the next question. Is it okay? And if you have any doubt on this particular question? Yes. Okay, fine. Now I shall move on to the next question. Okay. Yes, great. Fine. Now question number 11. Minimum number of states required in a DFA to accept language a power nk such that n is a positive integer constant and variable k greater than or equal to 0. K value minimum start with 0. So that means the strings like k value 0 means it is a power n into 0. N value is a constant. K value 1 means n into 1. And k value 2 means it is n into 2. Like this. Okay, it is all depending upon what is the constant value you take. For instance, if I am taking n is equal to 1, n is equal to 1 in the sense you can have the strings like epsilon, single a, 2a's, 3a's, like this. So that means it is a star. So a star means one state is required. Starting state, final state, you can give a DFA. Similarly, if n is equal to 2, for example, n is equal to 2 means 2 into 0 is epsilon, a power 2 into 0. A power 2 into 1 is a 2s, 2 into 2 is a 4s. So you will get even number of a's. That means it is a whole star. So for this, we can have a machine like this and with the two states. as a k value defined as 0, that's why we are getting for n value 1 we got one state, n value 2 we got two states. If it is n greater than or k greater than or equal to 1, then an additional state is required, because we can't take starting as a final in that case, as epsilon is not available. So it depends on the n, not on the k, and n plus 1 states. Sorry, not n plus 1, it is n states. Simply n states. So we require n states. Okay. Yes, sir. Yeah, for example. Yeah, that's what I am saying. Even n is equal to 3 if I take, for example. If I take n is equal to 3, you will get the strings like epsilon, 3a's and 6a's, multiple of 3a's will come. In that case, you will get a finite automata like this with 3a's, multiple of 3. That's why we have taken n states. Is it clear? Abhijit Singh. Now let's move on to the question number 12. Consider the following regular expression a star, b star, c star, whole star, which of the following is / are equivalent to the above regular expression. So one or more options may be correct here. Option A star plus bc whole star. Option B, a star plus b star, c star whole star. And option C star plus a star, b star whole star. And option D, both B and C. Actually, for this a star, b star whole star, b star whole star, a star, b star, c star whole star, you can get all combinations of A's, B's and C's. It can also be written as A plus B plus C whole closure. It can also be written as A plus B plus C whole closure. All combinations of A's, B's and C's. So actually this particular thing is not equivalent to option A. The reason I will tell you. We can't get a string like, for example, BC star you mentioned, right? Okay, let us suppose I want a BAC. BAC kind of strings are not possible, because in the first instance if you take B, and in the second instance A if you want means, C if you want means, definitely BC star you have to take. Before every C, B definitely come. So BAC kind of strings not possible in A. This is okay, this is okay. Any string of A's and B's. Actually, the combinations of A's and B's and C's, when sigma is equal to A comma B comma C, and combination of A's and B's and C's can be written as a sigma star. Okay, sigma star. Sir, previous question explained. Question number 10. Na? Question number 10 is very simple. Minimum number of states required in a DFA to accept all strings over alphabet 0, 1, where each string should have odd number of ones end with 0. So 1, 0 minimum string, 1, 0, 0. What I have done is first 1, 0 I took. And before 1, 0, any number of zeros are possible. After 1, 0, any number of zeros. Because it is supposed to end with 0, there is no restriction on zeros. Abhijit. And odd ones, single one followed by 0, 3 ones like this. And even if after 0 also, if 1 comes, if a 1 is sent to the C, then ends with 1. If you send to B, even ones will accept. That's why I send to A, so that odd ones are accepted. Okay. Now coming to the question number 13. Minimum number of states required in a DFA to accept all binary strings where each string contain at least 2 zeros and at most 4 ones. At least 2 zeros and at most 4 ones. Actually, the DFA can be defined like this. At least 2 zeros, that means minimum 2 zeros are required. So after 2 zeros, we can have any number of zeros. Okay, then after 2 zeros, maximum number of ones must be 4. Maximum number of ones must be 4. So I can, actually this space is not sufficient here. I will just give a DFA here. So number of states, first let me explain. Actually, one dead state will come here. At least 2 zeros means it is a 3 into 5, 15 states plus 1 dead state. So total 16 states will come. I am writing here, please observe. At least 2 zeros and at most 4 ones, it is like this. So after minimum 2 zeros, we can accept the strings, and after that either single one comes, it will accept, double one comes, it will accept, triple one comes, it will accept, 4 ones also, at most 4 ones. not more than this. Okay, and again, after 2 zeros, minimum 2 zeros. Even if you start with 1 also, then without having 2 zeros, we can't go. Like this also it is possible. After 2 ones also, we can have zeros. After 3 ones also, we can have minimum 2 zeros. After 4 ones also, we can have minimum 2 zeros. And ones can be like this. And after every 2 ones, 2 zeros, we can have any number of zeros like this. And why dead state is required? If fourth one, at most 4 ones, when fifth one comes, it has to go to dead. So from here it will go to dead. From here the 1 will go to dead. From here also 1 will go to dead. So total 3 into 5, 15 plus 1, 16 states. Option D would be right option. And you can just see once this DFA. If my, just a moment. Is the DFA visible? Okay, fine. Okay. Now let's move on to the next question. Last question. Let L1 is A power n and L2 is B power n and n value greater than or equal to 1. Now consider the following statements. L1 dot L2 is regular, L1 dot L2 is A power n, B power n greater than or equal to 1. Which of the following is correct? So actually it is a concatenation of two things. A power n means 1A, 2A, 3A's and so on. It is concatenated with 1B, 2B's, 3B's and so on. So the strings of concatenation is like AB possible, ABB possible, AAB possible, AABB possible. Not necessarily be S followed by same base. So that means L1, L2 is not A power n, B power n. We may have different B's also. This is wrong. But concatenation of two regular language is regular, and regular expression is AA star, BB star, which is not A power n, B power n. So only one is true and two is not. So that's all for today. I hope you people have enjoyed the session, and this type of questions you can prepare in the theory of computation, and push down automata and Turing machine level of questions will not be asked in ISRO and NIELIT. Only regular languages you can just concentrate. Okay, that's all for today. Thank you so much. Thank you one and all. Please do subscribe the channel if you have not yet done it, and do share with your friends, and like the session if you are really liking it. Thank you so much. Good night, and we'll meet again in the next session for digital logic. Thank you so much. See you all. Bye bye. Good night.